This video is a video about adding and subtracting polynomials. A monomial is a real number, a variable, or a product of a real number and one or more variables. Some examples of monomials are the constant 26, the variable x, the squared variable y squared, or the product of a real number 26 and the other variables x and y. So 26xy squared is a product and it is considered a monomial. A polynomial is a monomial, or it's a sum of monomials. So a polynomial could be the monomial x squared y cubed. It could be the sum of two monomials, 5x squared plus the constant monomial 2. Or another example of a polynomial is 3x squared plus 2x minus 7. When we look at each of these examples, we have in the green x squared y cubed, we have a monomial, and we can name that monomial by its degree. The degree of a monomial is considered the sum of the exponents of its different variables. So the degree of x squared y cubed is 2 plus 3, or 5. So this has degree 5 for a monomial. Our orange expression, 5x squared plus 2, is a polynomial. It's made up of two different monomials, the sum of 5x squared and 2. 5x squared is a monomial of degree 2 because of the exponent 2. The constant 2 at the end has no variable and therefore it has no degree, so that this monomial 2 has degree 0. All constants have degree 0. Our third example of a polynomial in the red is 3x squared plus 2x minus 7. This polynomial has degree 2, and that is because the greatest degree in all of its monomials is degree 2. 3x squared has a degree of 2, 2x has a degree of 1, and the constant minus 7 has degree 0. So the entire polynomial is considered degree 2. Each of these three polynomials are written in standard form. They're written alphabetically and then with the degree of the highest monomial, the highest degree of the monomial is the first term, and then they go in descending order. It's important that we know how to name monomials and polynomials because it's going to help us when we go to combine like terms and we start adding and subtracting polynomials. Here are some more examples of monomials and their degrees. 5x is a monomial with degree 1 because while it's not stated, we do have a power of 1 for this x. So that's degree 1. 5x to the second has degree 2. 5x squared y has degree 3 because we know that there is an exponent of 1 here, so 2 plus 1 is 3. And then finally, constant 5 has degree 0. Polynomials, as mentioned before, are named by their degree, and they are also named by the number of terms. When we name a polynomial by its degree, it is by the degree of the highest monomial. Constants are degree 0. Linear polynomials have degree 1. Quadratics are degree 2. Cubic polynomials have degree 3. And fourth degree and above are simply named by the number. Polynomials named by their terms. One term, like we've been talking about, are monomials, and then polynomials, when we start having a sum of monomials. If we have 2 monomials added together, that's considered a binomial. Bi meaning 2. 3 monomials added together is considered a trinomial. Tri meaning 3. 4 and above, we simply name them polynomials. When we're adding or subtracting monomials, we have to make sure that terms are alike. So in our couple examples here, we have 2x squared plus 7x squared. Because in this first example, the x squareds are the same variable and they are the same degree, same exponent, they are considered like terms. So we have 2 of these animals plus 7 more of them, which means we have 9 of this animal x squared. So 9x squared is our answer. In our second example, we have a product 8x squared y, and we're subtracting 3x squared y. Again, we need to make sure they're like terms. We have x raised to the second power times a y, and we have, that is the power of 1. And in our second monomial, we also have an x to the second power and then multiplied by y to the first power. So these are like terms, so we can subtract. 8x squared y's minus 3x squared y's are 5x squared y. When we're adding and subtracting polynomials, again, we need to make sure that we are adding or subtracting like terms. And you may find it easier to line them up vertically like you do when you're adding or subtracting numbers of 3 or more digits. So for example, I would rewrite this problem as 2x to the third plus 4x squared minus 3x plus 0. The reason I'm adding a 0 on at the end is I'm holding I'm holding a place value, if you will. I'm going to subtract then the polynomial 6x cubed, and here I'm lining up like terms underneath one another. Plus 5x squared minus, I didn't have a term with an x to the first power, so I'm going to add a 0x again as a placeholder, and then plus my constant 4. Oh, I'm sorry, it was minus of 4. Minus 4. And I'm going to subtract that entire polynomial. So in order so that I don't lose signs, I like to think of subtraction as adding the opposite. So I'm going to change all of these signs to the opposite. So now I have 2x to the third, and I'm taking away 6x to the third, so I'm down 4 of those same terms, negative 4x cubed. My next monomial or term are x squared terms. So I have 4x squared, and I'm going to take away 5 of that same term, type of term, 5x squared. So that means I have negative 1x squared. I have a minus 3x, and I'm going to add a negative 0x, so that leaves me with a negative 3x. And then my constant, I have a 0 plus 4, so that's a positive 4. So my final answer is negative 4x cubed minus 1x squared minus 3x plus 4. This is a polynomial. Its degree is 3, or it's cubic, because the monomial with the highest degree is the leading term in the expression negative 4x cubed, and that has degree 3.